Okay, so let's start solving this one, which basically does not look like the previous ones where it was easy to isolate the trig function. It looks like I have two terms that both have a sign in common, so it looks like we have a factoring preliminary step to do. So if I take out sine x, I'm going to be left with tangent of x plus 1 equals 0. So this is basically like solving a quadratic equation that you set equal to 0 and then you pop out your solutions. So I have two pieces. If these two things are equal to 0, I either have the first piece that's got to be equal to 0, or I have the second piece that's got to be equal to 0. And then that second piece, I can go ahead and isolate my trig function. So now basically I got two things to worry about. Either this guy, find all the angles that work, or this guy, find all the angles that work. And then I only keep, I guess, 4 of them because our direction said, hey, give us 4 solutions, or what did it say? Oh no, it just says solve, so I have to give all solutions. All right, so sine is 0 when we're looking between negative pi over 2 and pi over 2. If I use my inverse function on my calculator, it'll just give me 0 degrees, because remember, sine on the unit circle is just a y value, and 0 degrees or 0 radians is the answer. So I basically have 0, and then I can pick up more solutions if I keep going the period of sine, which is 2k pi. So there's one of my answers, I guess. 0 plus 2k pi, which just means just those multiples, even multiples of 2 pi. And then as far as tangent is concerned, tangent is negative in 2 places, in quadrants 2 and 4. So I can either use the inverse feature on my calculator, or just say, all right, I have 2 answers, one in quadrant 2 and one in quadrant 4. Tangent is opposite over adjacent, or if I'm standing here, opposite over adjacent. And that's a special triangle we recognize. So basically, I have one answer that has a reference angle of 45 degrees. And then I have another answer also that has a reference angle of 45 degrees. If I want to go in the positive sense, I don't have to. I can go in the negative sense and get a negative pi over 4 as one of my answers if I want to. So based on the way I've drawn it, I guess it's 45 degrees short of 180, so 135 degrees, or 3 pi over 4. And since the other angle in blue, remember, like we said in class, is right across from that 3 pi over 4 in red, it's just pi away. Since they're right across from each other, if I add pi, I'm going to pick up the blue angle anyway. So why bother and go look for the blue angle if I can pick it up by just adding a pi to the answer that I've gotten here? So pi k, by the way, or k pi. Multiples of pi will give me the blue angle also. So that's all the solutions, for example, for part A. One came from sine x equals 0. The other one came from tan x equals negative 1. And again, that's not the only way to represent the answer. You could also, if you wanted to, go and use the tan inverse feature on your calculator. That's going to give you, if you do tan inverse of negative 1, that's going to give you that negative 0.78, which is negative pi over 4. If you go to degree mode and you're more comfortable with that, and you do second enter to get the last entry, notice that's negative 45 degrees, or negative pi over 4. So if you thought of it as, hey, I'm just going to go and use like only this guy, this angle right here, negative pi over 4, and then I'm going to add this green pi to pick the other one, and then back and forth and back and forth. This would also be okay if your answer had that form. So there's different ways to represent the answers. All right, next one we're going to look at. Looks a little busy, but I want you guys to think of this like, since I see sines and sine squares and I can't isolate it easily, I want you to think of this like you would think of this quadratic function, where basically sine is like your x. That's a sine theta squared, remember? So if I think of it as that quadratic function, the quadratic function is factorable. We'll have like 2x and x, and you can use the methods of factoring I showed in the videos in class way at the beginning of the semester, however method you want to use, plus 4 minus 3. So if I solve that quadratic, I would get my answers as such. And if I think of this trig equation as a quadratic involved with it, I basically have 2 sine of theta squared plus 5 sine of theta minus 12 equals 0. So my quadratic function is a function of sine theta, and I can factor that as 2 sine theta, so like sine theta is like my x. And then I can have a minus 3 and a plus 4, and if I go and FOIL that out or distribute it out, I'm going to get back this function that's quadratic in sine theta. So anytime you see a combinations of different degrees of sine or of the same trig function, maybe you're dealing with just like a quadratic function. So now I'm going to pop out my 2 solutions, and remember it is important that you have a 0 on one side so that you can set each factor to 0. That gives me sine theta is 3/2, and if I set that guy equal to 0, I get sine theta is equal to -4. And if I keep going, I think this piece is quicker to deal with. If I take inverse of both sides, notice this piece chokes because -4 is not in the domain of the sine function, so no theta comes out of the first piece. If you didn't see that or think of it right away, if I go second sine or sine inverse of -4, I am going to get a domain error. So there's no such angle whose sine is -4. So the second piece chokes, I don't get an answer there. For the first piece, I have a 3/2. Well, 3/2, remember, is bigger than 1 also. So if I do that, it seems to be, if I try that and think, oh, they might cancel, again, this guy is going to choke too because it's outside of that -1 to 1. So if I do sine inverse of 1.5, again, outside of -1 to 1, it chokes, so no theta pops out of there, which means this equation has no solution. I tried factoring it, I tried getting the trig function equal to a number, but I was unable to continue from there and find any theta that works for that equation. All right, let's go look at the last one, which is kind of like part B. It's got sines and sine squares, so I'm thinking I'm leaning towards a quadratic. So if I'm going to deal with a quadratic, I need to have it set to 0. And again, you're thinking of this like if you had something like y squared minus y minus 2 equals 0. That would be factorable into y minus 2, y plus 1, and that would pop out your 2 solutions, and you'd be good to go. And for this one, since sine x is what I'm trying to isolate, I'm going to go ahead and factor it. So I have sine x squared and then sine x and then a constant. Kind of like here, I had y squared and then the y and then a constant. So I must have a sine x here, a sine x there. And then my factors -2 plus 1 to get the negative sine x in the middle. Again, if you go ahead and FOIL that out, you're going to get the original equation with a -1 sine x in the middle. But since I have it set to 0, I'm going to pop out my two pieces to analyze. So there's one of them. I'm already not liking that because it's outside the range of 1 and -1. So again, if I do my sine inverse on this and try to cancel the signs, this guy chokes because it's outside of the -1 and 1. So that gives me, well, undefined. Since we're solving this equation, we won't say undefined, we'll say no solution pops out of that piece. But for this guy, we think of quadrantals because of that -1 value. So I can think of that as, if I want in the positive sense, 3 pi over 2. If you want it in the negative sense, you would go to -pi over 2. Your choice. I'll just go ahead and think of it as 3 pi over 2. And then since the sine function is periodic and repeats every 2 pi, I'll add 2k pi to it. And that's it. Equations, trig equations.